Hello guys, you are welcome to Royal Learning Channel. In this video, we are going to be talking about velocity time graph. And throughout this week, we are going to solve different questions on velocity time graph. If you have been finding it difficult to answer questions on velocity time graph, this video is for you. I'm going to make it simple for you. I will start from simple to complex. So if you are new here, kindly click on the subscribe button to follow Royal Learning Channel. Then if you are watching me on TikTok, don't forget to follow, like, share, and leave comments. So let's go. Before we solve these questions on velocity time graph, let me briefly explain velocity time graph. They call it velocity time graph because a graph of velocity is plotted vertically against time taken horizontally. So a graph of velocity against time taken is called what? Velocity time graph. Then velocity is always in meter per seconds and the time taken is always what? In seconds. So if they say that an object travels vertically upward, it must not go on an horizontal, on a vertical line. It must not go in this way. It's wrong. Why? Because if it goes in this way, it will only cover the what? The velocity axis. It will only cover the velocity axis. And don't forget that we call this what? A graph of velocity against time taken. So when they say that an object travels vertically upward, it will go in a slanting form. So it will start from what? From zero. Then it will go in this form, slanting form. And it maintains a constant speed. So that is from where it stopped. So it will go like that. And it maintains a constant speed and decelerated. So deceleration means going down. It will come back. It will come down. So this is a velocity time graph. So this line is for acceleration. So this triangle is for acceleration. So this line is for what? For constant speed. This is for speed. Why this line is for deceleration. Then don't forget that deceleration is the opposite of acceleration. Deceleration is the opposite of acceleration. So let's quickly talk about the calculation aspect of it. If they ask you to calculate the acceleration, then acceleration is A. So you can use two methods. You can apply two methods to calculate acceleration on velocity time graph. Don't forget that whenever they ask you to calculate acceleration on velocity time graph, you are going to use your graph to answer such question. So you use your graph to answer the question. So when they say calculate acceleration, it's either you use formula method or you use what we call gradient method. So the formula method, acceleration is equal to change in velocity divided by the time taken. Is change in velocity divided by the time taken. So let's look at this graph. This is what? This is velocity axis. So the starting point is what? Is u. Our initial velocity means u. U is what? Initial velocity. YV is the final velocity. So T is the time taken. So our initial velocity, which is u, is our starting point. So it will be 0. Then don't forget that this is what? Velocity axis. So the final velocity will be where this what? This line stop. So our final velocity will be this point. Let's call it point X. So it will be point X. So what will be the time taken? The time taken for that object to accelerate. The time taken for that object to accelerate is from here down to this place. The time taken for the object to accelerate is from here down to this place. Then if they ask you to calculate deceleration, deceleration. So the object decelerated from this point. So the time taken is from here down to this place. So deceleration time taken is from here down to this place. Why the what? The final velocity minus your initial velocity will be from this point. So when you trace it down is 0 at this side, then to the final stage velocity you read it up is this x. So then another method is by using the slope, which is called gradient. So you can also use slope to calculate acceleration. You can use slope to calculate acceleration. So according to our slope, we say change in x. Don't forget that this line is y-axis. This is y-axis, then this is x-axis. So our y-axis is now velocity axis. So we are going to change in what? In velocity divided by change in what? Time taken. Or we say y2 minus y1 over x2 minus x1. So according to this graph, what is our y2? Don't forget that this is our y-axis, which is the same thing as velocity axis. So our y2 is the what? The maximum. So this point is our y2. So our y2 is x, while our y1 will be the starting point, which is 0. So the x-axis is your time-taking axis. So my x2, where the what? The object accelerated, so is this point. So let's call it B. So my x2 will be B minus x1 is 0, which is my starting point. Then another one is calculation on the distance. How can you calculate distance on velocity time graph? So what will be the distance? To calculate distance on the velocity time graph, it will be equal to what? The shape that appear on the graph. The shape that appear on the graph is equal to what? To the distance. You use the area of the shape. The area of the shape that appear on the graph will be the what? The total distance. Then another one, distance is what? The area of the shape. Area of shapes. So another one is speed. So formula for calculating speed is total distance taken, then divided by the what? The total time taken. The total distance divided by the total time taken. That is what? The speed. So speed is total distance divided by the total time taken. So let's apply what I've explained now to answer these questions on the board. Now, let's look at the graph on the board. From the graph above, calculate Roman figure 1, its acceleration. Then acceleration is this slanting force. So what is the acceleration side? From here down to this place is our acceleration. Let's call it A. This is our acceleration. So from here down here is the acceleration. So we can use two methods. We can use A equal to change in velocity divided by the time taken. So Roman figure 1, change in velocity divided by the time taken. Then this is our what? This is our velocity axis. So the final velocity, what is our final velocity? On this axis, the last point. So we are going to trace this one to this place. So this 4 is our final velocity. So the final velocity is 4 minus u is the initial velocity. That is the starting point on what? On velocity axis. So the starting point is 0. So u equal to 0 divided by the what? Divided by the time taken. Divided by the time taken for that object to accelerate. Acceleration is from here down to this place. So from here down to this place is our time taken. So from here to this point is 10. So divided by 10. So which is equal to 4 divided by 10. 4 divided by 10 will give us 2/5. Then let's divide and convert it to decimal number. How many 5 can we get in 2? That's 0. Then in 20 will give us 4. So it will give us 0.4 what? Meter per second square. Since we are looking for acceleration, so the unit for acceleration is what? Meter per second square. Then the second method is to use your what? Change in y divided by change in x. Change in y. Your y-axis is your velocity axis. So that is the final minus initial. So your y, change in y2 is 4. The highest is 4. Then the lowest is the starting point, which is what? Which is 0. Then we are going to move to our x-axis. So then we are looking for where the what? Where the object accelerated. So acceleration is this line. So the starting point is 0. Then the last point is 10. From that where object accelerated. So it will be 10 minus 0, which is equal to 4 divided by 10. So at the end, it will still give us what? 0.4 meter per second square. So that is how to calculate acceleration on velocity time graph. So number 2 is the total distance. We are looking for the total distance. Roman figure 2. So to calculate total distance on velocity time graph, so we are going to look for the what? The area of the shape that appear on this graph. The area of the shape that appear on this graph. So what type of shape is this? What type of shape is this? This is a trapezium. Then if you like, you can break it down. Number 1, this is a triangle. From here to this place is a triangle. So from here down here is a rectangle. This is a rectangle. This is a rectangle. Then this is another triangle. So you can say that area of a triangle, the first one, plus area of a rectangle, plus another area of what? Of a triangle. So not to waste our time, then the whole shape is what? Is trapezium. So we look for the what? Area of what? Of a trapezium. So total distance now. Total distance is equal to total distance, because they say calculate the total distance covered. So total distance is equal to what? Area of a trapezium. Then what is the formula for calculating area of a trapezium? That is 1/2 into bracket a plus b times height. So area of a trapezium is 1/2 into bracket a plus b times height. Then how can we locate our a and b? How can we locate our a and b? That is the side AB. The two parallel lines on the what? On this trapezium are what? Are AB. The two parallel lines. So let's locate the two parallel lines. So this is the first one. Then this is the second one. That is from here to this place. This is the final point. From here to this place. So this is the first one now. What is A? From here down to this place. What's the length? From here down to this place. That will be from 10 to, if I trace this point down, that is 10 at this point. Then if I trace this side down, that is 20. So 10 to 20. So from 10 to 20 will give us 10. That is 20 minus 10. So my A will be 10. So 1/2 into bracket. That is from here to this place is 10. From here to this place is 5. Plus another 5 will give us 10. Or you say 20 minus 10 will give me 10. That is my A. That is this length. This length is equal to this length. Then the second parallel line. Don't forget that this is the first parallel line. The second parallel line is this. So from here down to this place. So from here to this place is 25. That will be my B. Plus 25 times height. So the height of this shape. What is the height? So from here down to this place is the height. So my height is what? Is 4. From 0 down to this place is height. So my height is equal to 4. Sorry, this one is 10. This is 10. So 1/2 times 10 plus 25 will give us 35, then times 4. So 2 here 1, 2 here 2. So 35 times 2 will give me 70. So 70 what? We are looking for what? Total distance. So distance in what? In meter. So the total